Hey, hello, welcome to the show. It's me, John Park, and it is time for John Park's workshop. So that's a good thing. Hello, QuinMan16 over in YouTube chat, and hello, how's it going? Going well, thank you. How about you? Dave Odessa, Johnny Bergdahl, Baths for Cars and Raspberry Pi Stuff and Computer Stuff. Hello, love your username. That's the people in our YouTube chat. And we've got a whole Discord chat right over here full of people. Hello, squid.jpg. Hey, Liz. Hey, Paul Cutler, Andy Calloway, Johnny Bergdahl. Who else do we have? I think that's it. I think that's who's here right now. Hello, Beatagraf Avdelhagen over in the YouTube chat. Howdy, hi. If you're looking for this chat right here, that's one of the main ones that we have active during live shows as well as all other times. It's our Discord server. You can go there by heading to adafruit.it/discord. Look for the live broadcast chat channel. That's where we're hanging out during the chat. But as you can see there's loads of other channels for all kinds of topics that you can dip into anytime you like. I'm excited about today's show. What are we going to do? So I've got a coupon code for you so that you can save a little bit of money in the Adafruit shop if you're looking to buy some things, build some projects. We've got a recap of the Tuesday show, which is the product pick of the week show. I have a CircuitPython Parsec that is extending on the ideas from last week. So I'm going to do a little bit of a series there with some of the touchscreen display stuff, I think. Lars does look exhausted. I noticed that. Guy, what were you doing all night? I don't know. I've got a Learn Guide recap, a little update actually, that we'll talk about for a moment. And what else? I've got a new project that I'm kicking off. This is the Homebrew Game Boy game, DIY Game Boy game thing. You might have seen a little teaser of it last night on Show and Tell if you stopped by there. Excuse me. Got to get my caffeinated water because I don't want to look like that guy. What else? And then I've got a bit of a... depends on the order that makes the most sense, but I'll do a little bit of a gear report kind of thing with this FPGA-based Game Boy handheld thing. That'll be part of me showing some of the development here on the Game Boy game. And I've also got another CAD 3D modeling tips and tricks intro segment thing, and we'll look at parametric modeling. That's kind of what the last two or three that we did were leading up to. Those were some of the sort of basics of modeling stuff by hand, but now we'll get into the real powerful stuff, the real useful stuff for precision and iteration and replication of design, modification, things that you might use for modeling, things for 3D printing and fabrication and CAD and laser cutters and that kind of stuff. Todd bought, yes, they make, I don't drink soda anymore for the most part. I drink all kinds of caffeinated waters. They're like soda minus the sugar. They're yummy. Favorite one is Dr. Cherry. Wonder what they're trying to rip off there. This isn't that one, but yeah, Dr. Cherry Vanilla, they call it. Let's see. So as I mentioned, I've got a coupon code for you. If you want to head to the Adafruit shop and get yourself a 10% discount on your order, then head there and use this coupon code. It's .matrix, 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 in honor of the .matrix gamer, which was the original name for the Game Boy. You can head to the shop. It's this place right here. Boy, those greens really clash. Let's go to new products. If you click on view all new products, that's a little better. You can see we've got some neat new stuff, a new long distance IR proximity and light sensor out, the Vicnol 4200. We've got this new iFixit Fix Hub, the cool smart soldering iron. And we've got this protective bumper for the Raspberry Pi 5, a new triple current sensor, amp power monitor, and more. So if you want some of that stuff and you want to save some money, then use that coupon code right there on the way out. Just type that into the coupon code field, .matrix, and you'll save 10%. Additionally, I'll mention, if you're thinking of getting some stuff and you're thinking of getting lots of stuff and you're wondering, boy, is there any free things I can get? Well, yeah, if you head to adafruit.com/free, you'll see right there, those are the deals going right now. So if you spend $99 or more, you get a free PCB coaster. You spend $149 or more, you get the coaster as well as a KB2040 microcontroller, which is a really neat one, particularly for USB HID projects. Drop-in replacement pretty much for a Pro Micro in any of your keyboard projects, MacroPad projects. If you spend $199 or more, you'll get the coaster and the keyboard, as well as free ground shipping with UPS in the continental US. And then if you spend $299 or more, you'll get a free Circuit Playground Express and the UPS shipping and the KB2040 and the PCB coaster. So those are all some enticements there. If you're thinking on spending a bunch, then that's what you might get. So head back here. Yeah. There you go. That's your coupon code. I might show that again later, but write it down or go buy some stuff immediately. As you may know, selling things in the Adafruit shop is how we keep the lights on here at Adafruit. So I think PT once described us as a content company, a learn guide company that happens to sell stuff. Of course, it's a little bit more complicated than that. We design things, put out libraries, support open source projects all over the place. So there's a lot of stuff we do, but being able to sell these things to you is how we pay ourselves and keep moving forward. All right, so next up we've got a little recap from my show that I do on Tuesdays, which is the product pick of the week. I pick a new product, give you a little demo, give you a huge discount on it during the show only, and here is a little 1-minute recap from that. It is the RP2350 HSTX to DVI adapter. This uses that beguiling little FPC connector that's at the base of our Feather RP2350. Is a more dedicated high-speed transmission line. It has, I believe it's 4 differential pairs that are designed to send that data at speeds that are high enough to make that kind of monitor happy, or the one I've got down here for my demo. I have this image that is a 320 by 240 BMP. It actually gets pixel doubled over to the monitor because 640/480 is generally the smallest that an HDMI display is going to accept. This is my product pick of the week this week. It is the RP2350 22-pin HSTX FPC to DVI video HDMI output converter adapter thing. Oh, yep, that was it. Right, next up, let me get set up here, bring some windows to the foreground, and I really should check my focus. How's that? Oh, that's much better. That's much better. Here we go. It is time for the CircuitPython Parsec.
CircuitPython Parsec.
All right, so for the CircuitPython Parsec today, I wanted to continue talking about touch screens and touch I/O and show you how you can place objects using the touch screen sensor. So this uses vector I/O to draw shapes. It's a really fast way to draw shapes on screen. And as you can see from the display here, when I touch the screen, I am setting the position of one of 2 points there. So I have a little blue circle, I have a little red circle, and they essentially alternate with my taps of the screen, which is useful for if you want to do things like draw objects and choose their radius or corner to corner. So we might do a little bit of shape creation, sort of drawing program kind of stuff with this as we proceed. But it's useful for all sorts of I/O things, or I should say it's useful for all sorts of user interface things, games, that sort of stuff. So the way this works, in CircuitPython, I'm importing a bunch of libraries: time, board, display I/O for drawing, vector I/O for drawing with panache, and the Adafruit touch screen library so that I can read that touch sensor there. In fact, you can see it a little nicer if I use something other than my hand blocking the camera there. I'll use a little stylus. So I set this up with display as the board display. It's a built-in display, so it's easy to set up. This is a PyPortal, by the way, that I'm using here, but this would work on any of our touch I/O capable screens. And then I'm doing a palette of a couple of colors here, and then I'm drawing 2 vector I/O circles. So one is using the color index 0 of the palette, the other is color index 1 of the palette. That's how I get that blue and that red. And then I'm setting them with a consistent radius at a couple of different X, Y locations, and that's going to matter in a second when we start redrawing these. I then append those to the main group, display the root group, and then I initialize my touch screen. As you can see here, this is on dedicated pins on the board that are reading X, left, right, and the Y, D, and YU, so that's down and up. And then we have some calibration here that's pretty standard. And we're setting the size of the touchscreen to be the same as the size of the display. And then we've got a couple of state variables here, P1 and P2, to hold those positions, initially set to nothing. And then during the main loop, we just simply wait for the screen to get touched. So P equals touch screen, touch point. That's, hey, we've noticed we've touched a point on the screen. If we have touched a point, then the first one, if it hasn't been touched, is going to get set to whatever the current point is. And we read that, which is X, Y, and pressure. We read the X at index 0 to be the circle 1X position. And we read the Y from the touch as circle 1Y. Then we sleep just as a kind of easy debounce here. And then the next point, next time I press, it's going to change the position of the second point. And so that is how you can set the position of objects in vector I/O on a touch screen inside of CircuitPython. That is your CircuitPython Parsec.
CircuitPython Parsec.
Alrighty, moving along. Let's see, I had a couple questions I wanted to check at. Someone asked, is this the Titano or the original? This is the original. Quinn Manna asks, this is the original PyPortal. So it's the, I think it's a 3.5-inch screen. And then the Titano is a bit bigger, 4.5 inches, something like that. This is actually such an original one that it is, I think, first batch, maybe purple no silk screen one that Lamore sent me when we first were getting ready to launch these. So you can check those out right here if you're wondering what the heck is this board he's using. Let me go find that. PyPortal. So the PyPortal is, it's out of stock right now, so is the Titano. The screen on that one is 3.2 inches, and then the Titano is, what are you, 3.5. Okay, just a bit bigger. Diagonal actually ends up, diagonal dimensions actually are deceptive there. So these use an 4 at SAMD51, as well as an ESP32 S2 as a Wi-Fi coprocessor. If you look at the, I want to say, what's the touch Featherwing? Featherwing. What is your name? Will this work? Touch. TFT Featherwing. Okay, yeah. So we have this one in stock, and this you can plug different feathers into, so that might be a good alternative. In fact, I have one right here. I should have used this one. So this is a 3.5-inch 480 by 320 TFT Featherwing V2 with capacitive touch, and you can plug a feather board into there. So that's probably a good alternate to the PyPortals there. It does basically the same things. Let's see, any other questions? Touchy subject matter, says Seagrover. Thanks, Seagrover. What's Bruce Lee doing there? Do I dare hover? Nope. Hi, Bruce. Okay. So next up, what do we have? I want to look at this updated Learn guide for the NES, Nintendo Entertainment System emulator that we have running on RP2040 as well as RP2350. So this was a guide originally published July of 2023, and then I just updated it with a new version of the PCB, new info, links to the updated code for this. This is a project that has taken NES emulation, ported it to the Pico RP2040. Now it's been updated to point, sorry, I'm not showing you the screen. Let me switch over. There we go. Here's the new guide. And by the way, you can get there just by going to Learn, and then in the new guides, actually just on the main page of Learn New Guides, you'll see it's the third one there. It says NES emulator for RP2040 and RP2350. So if you click on that, one of the updates is this now runs on both the RP2040 and the RP2350, and 2-player support has been added. So Frank Hoedmacher, hope I'm pronouncing your name properly, did this port to get this working on RP2040 in a few forms with some breakouts. You can see the different versions here. So here's it running on a RP2040 Feather DVI. Here it is on a Pico or Pico 2 with the DV demo base from Pomeroni. And here is the version using some different breakouts. So this will work with the Adafruit DVI breakout and the SD card breakout and a Pico, and again, either RP2040 or RP2350 work. I don't know if there's any automatic instant improvements running on the 2350. I think the frame rates were already fine, but it does have more RAM and more headroom, so it's possible enhancements will come in the future. But the biggest update here, I think, is that you can now do 2-player games. So Frank asked me to do a revision on the PCB so that we could, instead of using either a SNES connector or an NES connector, one or the other, both as player 1, this now supports 2 NES controllers. I used the NES form factor there to make it simple and a little more fit a little better to what you're emulating on here. And you can do this a few different ways. Someone asked, is it possible to update to use the Wii NES controllers with 2-player support? I believe that is possible. And if we look at, let me find the link here. So this is the new PCB, by the way. So you can see there I have now a couple of controllers there routed to different pins. The 2.1 update I haven't tested, but this routed, I think, 2 more pins that were useful for, I think it's this D3 and D4 pin on the connector, useful for light gun games. But since this is running on an HDMI display, you need a modified light gun. It's not. This isn't running on CRTs, so you can't use a straight up vintage light gun. I'm talking about the Zapper here. This gizmo here. An unmodified one isn't going to work on that, so I haven't bothered testing that. I prefer to just use those on a real NES on a CRT. But if you scroll down, there's a link to the PCB file. You can just have those made at a PCB house. This GitHub repo here from Frank, Pico Info NES, has info about running it with a Wii Classic controller, which has the little Wii Nunchuck connector on the end and can plug into our little I2C breakout. So that's a way to use the Wii Classic controller. So that info is all in here, and I believe, oh yeah, here's, okay, so yeah, I don't think, to answer Quinman's question, I don't think it runs 2-player with that right now. I think 2-player is limited to either the 2 NES ports, or as it says right here in this table, if you use an OTG on-the-go connector, 1 USB controller, and then 1 NES controller in either port. So that's how you can do 2-player. And I think I had a link, or a GIF rather. Yeah, here's a GIF of 2-player Bubble Bobble playing right there on the Pico NES. Yeah, Frank Hodemacher is the name, Andy Callaway, if that's you're asking, who created this. And all that info is in the Learn Guide, so go check that out if you're interested. And also, there is a nice 3D printable case that Gavin Knight made right there. So if you want to make a cute little baby NES to plug into, this is a nice way to put together a neat little, these make kind of a cool gift. Since I ordered 10 PCBs, I might put together some as holiday gifts for some friends and family. Yeah, really cute case. Love that. All right, so that is the updated Learn Guide on that. And then next up, I'll leave this here. I'll segue into the new project, which is the Game Boy project, by first doing a bit of a gear report. I've had this for a while, and I don't think I've shown it on the show before. This is the Analogue Pocket, which is a handheld game machine. I have one right here, but I don't want to take it out of the dock at the moment because we're gonna look at it through HDMI. So Analogue Pocket is a Game Boy DMG form factor handheld that uses a FPGA, field programmable gate array chip, to essentially, I hate to use the word emulate because people like to make a distinction between emulating hardware and emulating software, but essentially to emulate the hardware of the Game Boy so you can play original cartridges on it in its most basic form. So it'll play Game Boy, Game Boy Color, and Game Boy Advance games with cartridges. So it's got a, yeah, in fact, you know what, I'll take mine out of here so we can look at it. Hopefully that'll all work when I put it together. So I happen to have this one here that is a translucent green, which I love. But you can see there I've got a Game Boy cartridge plugged in back there, and it'll fit Game Boy Color and Game Boy Advance. And then you can go in, let's back out. You can go into the little OS that runs on there. Why don't I put this in the overhead? That'll make more sense. Do it like this. So I can go into the little OS that pops up. I think you can set a setting that'll say if there's a cartridge plugged in, it'll just launch the cartridge, so it feels a little more like a authentic experience. And this is now going to grab that cartridge's ROM, does it pretty quickly, and play it in an FPGA that is acting like authentic hardware. So it's acting like a Game Boy, or it'll act like a Game Boy Color, or it'll act like a Game Boy Advance. And the benefit of this over software emulation is it'll pretty much play any cartridge. I don't know that there are any that don't play. I think it plays the whole library of those three systems. And then they can write different cores for it so that you can also get cartridge adapters for a few other systems. So I think Game Gear, Atari Lynx, some of the TurboGrafx stuff, Neo Geo. There's little adapters so you can plug those cartridges in, but they basically, when it sees those, the operating system on this says, okay, that's what I need to reconfigure the FPGA to be, and now it'll be that system. So it's a cool system, and one of the other things that makes it really neat is that it has the USB-C here is not just for charging, but you can also plug it into this little optional dock here, and it'll output HDMI. So I'll plug that in right now. Actually, let's see if it just recognizes it. Yeah, there it is. Okay, so that's, I think you're going to hear the music from that now too, on top of me. So let me see if I can back out of that so we're not competing. Quit the cartridge there. There we go. So it'll play over HDMI, and it'll accept controllers. So I've got a old Xbox 360 controller just kind of plugged in over USB. There's a couple of USB ports on there, but you can also use wireless controllers, both Bluetooth and 2.4 gigahertz, which is pretty cool. And there are some 8-bit DOE controllers that are, I think, particularly compatible, that are SNES-shaped ones, I think. So this, let me go back here. This thing, this Analogue Pocket thing, has a couple other things that I'd like to mention. One, the black one and the white one there, those are generally in stock now. They took a couple years to come out from when they first funded or had pre-orders on them. But now they're not terribly difficult to get. They cost $200 plus shipping and tax. So they're not too far out there versus buying original hardware and modifying it to have a pretty screen on it. So they're pretty neat. The other thing is this particular piece of gear has a second FPGA in it, and they have released access to developers so that they can write their own cores for it. So you can get a core that'll play different arcade cabinets. You can get a core that'll play Super Nintendo. You can get a core that'll play Sega Genesis. So up into the 16-bit era, there's even ones for like an Apple IIe and an Atari 2600 and stuff like that. So it becomes a pretty neat machine as a general emulation machine, particularly once you put it in the dock and hook it up to a TV for games that are better to play maybe co-op on a larger screen. So that's what I'm using right now for some of the development of this Game Boy game that I'm working on, but it's absolutely unnecessary. You can get a traditional, I've got a Game Boy Pocket sitting over here. You can still pick these kind of things up pretty cheap, or Game Boy Color rather. Still pick these up pretty cheap. And the game that we're developing will run on an original Game Boy, DMG, a Game Boy Color, Game Boy Pocket. I actually don't remember what Game Boy Advance compatibility is with regular Game Boy games. I think it is, right? So that's the gear that you'll see me using here. And every once in a while they come out with these different color editions of these, and they tend to sell out really quick and then get scalped for too much money. So you can see they did Game Boy Color ones. They had done some aluminum ones that were outrageously expensive but pretty sexy looking. Classic colors. This was when they had done those transparent ones. They did a glow-in-the-dark one. But anyway, that's the system I'm using. So I just wanted to talk about that. It doesn't need my help. It sells like crazy, and I'm not paid to say this. I don't get any kickback or anything like that. I just think it's a neat piece of gear. There are other great ways to play Game Boy games today. You can get a $60 or less software emulation machine from, what's the one I had? Had a little Anbernic, maybe. There's a few brands that are really popular out there for playing your ROMs on, but they won't play original cartridges, and that's one of the reasons I got this, is to play original carts on there, which is pretty fun. Okay, so that's the gear. Now, what's the project? So I've mentioned this before, but Dookie Demastered is this. Oh, thanks. Squid.jpg said, yeah, Game Boy games work on the GBA. And Secret of Mana co-op is killer on it. Oh, very cool. Oh, that's interesting. Squid.jpg said the official Nintendo Switch controllers to use with their emulation thing, Nintendo Switch Online stuff, those are, I think, Bluetooth, and Squid.jpg said those will work with a Pocket dock as well. So yeah, so what launched me into this? The Dookie Demastered album was announced, and they took the Green Day, the band Green Day, took the album Dookie, and they had each song demastered to run on obsolete gear, like a little Fisher-Price record player, and off of a floppy disk, and on a Teddy Ruxpin, and an answering machine, on a Billy Bass, a little keychain music clip player, and as you can see, oh, there's a mini disc, there's a music box, there's a doorbell, a toothbrush, 8-track, and Game Boy cartridge. So they made 25 of those, so there was no chance of anyone getting one, and I decided, okay, what if I want to just make it myself? I don't actually know what they made the game to look like, or the gameplay to look like, but it plays a 4-track, essentially what the Game Boy has 4 tracks. It has a noise track, which is usually used for drums. It has a couple of PWM tracks for like bass and melody line, and it has a wavetable. Is that right? I forget what the 4th one is. Some kind of like a wave, a little more sophisticated than the square waves of the PWM track. So it's a sort of tracker, Game Boy chiptune sounding version of Welcome to Paradise, and I wanted to see if I could make that myself. There you can see is the cartridge. That's what it sounds like. I won't play a lot of it so we don't get taken off the whole internet. But there it is. I love that Game Boy sitting in a recording studio under a shotgun mic. There's the cartridge there. Oh, look, there's a graphic. Okay, we could maybe try to steal that. But what the bigger question is, what does it take to make a Game Boy game? So I'm gonna show you what I'm doing to create my own. So here is a piece of software that makes it dead easy. It's called GB Studio, and I'll go there. GB Studio, it is free and open source. You can donate. And as it says there, it's a quick and easy to use drag and drop retro game creator for your favorite handheld video game system. I believe you can do Game Boy, Game Boy Color, and Game Boy Advance on it. We're just going to do Game Boy. And it runs on Windows, Linux, Mac OS. It is a really beautiful dev environment that's very friendly. Allows you to grab canned assets and canned behaviors, even start from a template for the type of game you're making. You can throw all that away and do it all from scratch if you want. You can create your own pixel art. You can use pixel art that you buy on itch.io. There's a lot of artists who sell different like sprite packs. I'll show you how you can make your own. And it allows you to wire up behaviors and create the music right inside the program in a tracker, or import tracker music. Allows you to export essentially 3 formats that we care about. So there's a ROM file, which is what will end up burning to a proper cartridge or opening in an emulator. we can create a Pocket file that runs right on that Game Boy Pocket there that I was showing you. And we can also export a little HTML zip file thing that you can upload to itch.io and play it in a web browser using a Game Boy emulator that's in the web browser. So a bunch of ways to share the stuff you make, so it's not just locked into this esoteric, bizarre, I want to burn a Game Boy cartridge kind of thing. But a really nice tool. Last time I looked into this stuff, it was a much more complicated proposition to author a game as well as to get it onto a cartridge. So that's what I'm using here, gbstudio.dev. I've dropped that in the link in the chat if anyone's interested in looking for that. That's what I'm using for this. And in future workshop episodes, I will show you the process of dumping ROMs and flashing a cartridge and some of the hardware around that. So we'll go through the full steps. But I first just wanted to take a look at this software in action and what I'm doing to put together a little example file that you'll be able to use, and this will be in a Learn Guide. So this is the main canvas, the game world as it's called, inside of the GB Studio. And I based this on one of the sort of template files. You can open up a template of sort of RPG game. You can open up a template for a platformer and a few others. So this is based on the idea of an RPG game. I'm going to have you go find a couple of items and then play music on a radio. So you can see if I click on these little scenes here, we can see how things are connected to each other, which is kind of interesting. So initially the game will play whatever your logo is, kind of your studio logo. Mine's from Lars Go Games. And that has some little behavior that it will send it to the title screen of the game. So this is just a single PNG file that I made there. And it has some behaviors associated with it. If you look over on the side here, we can see that it has some little logic here about what happens if someone clicks some of the different buttons. We bring up little dialog boxes. So, for example, right here, we get a nice hover over of the loop of what this scene can do. Is a display choice element that can bring up this play or quit dialog box. You can see it's easy to just change. Don't play. So that's what it'll look like if I click the B button instead of the A button, or move down to that. So then there's logic about, okay, what happens if that play button or that don't play button is pressed, and one of them is going to change the scene. If I press don't start or don't play, I just am heading back to the logo screen. If we press the play button, it's going to go to create the player in the scene where I've placed them. So I can just move this around and put the player in different scenes and starting points. You get a nice little dotted line there that's telling you where that's going to be. So that's how the game will start. The scene itself here, I've just got a couple of rooms, so I'm going to build like a little mini apartment. So in this room here, I started with some existing artwork and just modified it. And there are a lot of neat debugging tools and things in here. So for example, there's a limited number of 16 by 16 pixel tiles that can be in a scene on a Game Boy. So you can't just create wild, fully unique artwork all over the place. You got to have a lot of repetition, which is why you'll always see things like bushes that look identical to each other everywhere in your scene. That wasn't an artistic failing, that was a technical thing. So we only have so much space to store this little screen of tiles. And we'll dig into that more later and look at some of those debug screens. They're pretty cool. But in the case of this, I have the one background screen. You can see here I have some lines blocking where the player can go. That's these red lines here. So that's as simple as, drawing them in. So now my player could walk all the way to the edge of the screen there if I wanted, or I can put that blocker back in place. We can create little collision items. And then I have a couple of sort of special items that you can see here. This one is called an actor. Pretty much anything that you interact with is an actor. So this is a little boombox sprite that I made, and it has some behaviors associated with it. So you can see where is it going to be on the screen. We can set that with an XY or just drag and drop to put it somewhere. Which sprite we're using. So I could say, oh, let's make this look like a dog instead. We've got some assets that have been saved in the directory of the scene or the game project that we're using. So I've got my little boombox there. These can be 4 colors with a color for transparency. So there's a limited palette you'll use. And then I've got some little logic here. So on interaction, if we interact with it, I have some variables like do I have a battery and do I have a cassette tape? If I don't have those things, then it's going to throw up some little warnings and play a little sound. And then if I do have those items, it will play some music that I've selected here. Speaking of music, we can go into a sort of different region of the tool here. You can see I was originally in this game world where I'm looking at the sort of flow of my scenes and the details of my scenes. But we can change what sort of mode we're editing in, a different module here. And so if we go into music, we have some different songs. This is my little Welcome to Paradise, which right now just has some little drums being played there. I'm going to go tracker mode actually, which is how I was using it. So we have these vertical columns of the 4 channels of sound. So we have that PWM that's going, and we have, which is our drum over here in the noise. I think I can preview this. Why are you not wanting to preview? Why do you not want to preview? I can't remember why. All right, well, we'll see that in a second when I actually compile it and we play it. But yeah, normally you can, if you're not forgetting your head like I am right now, you can actually go and preview the song there, which is very useful while you're working on. Oh, there we go. I think I fixed it. Okay. So this is just going to loop right now. I've just created a small little looping snippet that's reminiscent of, and hopefully not going to get sued for, doing a version of Welcome to Paradise. And like I said, back here in the game world, when I click on this radio and my conditions have been met, I've got the items I need, there is a play music track call out here that I've added as an event that will allow me to pick from the songs that I have saved in this game project. So it plays that little Welcome to Paradise one. Another thing I'm going to do is spew out some music notes when I click it. So I have a little launch projectile item here, which sends out a little sprite of some music notes. So any of these events I'm adding are kind of at your fingertips. So if I also want to make the cat move or something when the music starts, then we can click essentially from drop downs. This is all very drag and drop and experimentation friendly. You barely have to read the manual. So I can go into actor, move, or move relative to, set them looping in an animation, make another actor say something. So those are all pretty much anything you can do as an event in the game is going to exist right here. And that includes scripting things, conditional stuff, control flow, dialogues and menus, even little math blocks you can use, variables you can create, and on, little timers you can make. So lots of options in there for any kind of complexity. And you can see one other thing before I actually demo this is there are other types of not just these little collision objects that I can put this red line here, but I can also add a trigger that doesn't have to be associated with a sprite. And this trigger here, we can say, hey, add an event, I want to teleport somewhere, or if I touch that spot, I want to go back to the main menu. So that's how I'm creating a little doorway, essentially. So if I touch these two little orange collisions right here, you can see the little dotted line shows me, oh, we're going to move the character as if they've just come through this door right here, and vice versa. So those two rooms just connect back and forth to each other. It's a little like HyperCard kind of thing. You get a nice little flow, visual flow graph of how things work. So what I can do is I can compile it right here in the game engine. This is the fastest way to test stuff out. And when you're happy with that, you can then test it on real hardware, which I'll show you too. So here you can see we have a wipe on of that first screen, and then a period of time, and then it just automatically jumps over to this one here. I'm not calling it Dookie Demastered, I'm calling it Dorky Demustard. I don't know if I'll stick with that, but it made me laugh. There are keyboard keys that are assigned to or mapped to start, select, A, B, up, down, left, right for a Game Boy. Those are the controls you have. So if I press Z, that's the A key. I'll say, yeah, let's play that. And now it just places my little sprite in the scene. This is a animated sprite sheet, so it has a couple of frames of left. So you see a little walk cycle. Left, a couple of frames of right. You see a little walk cycle. Up, down. So there's a few little frames there to give it some animation. I'll show you what that sprite sheet looks like. And then the behavior here is, okay, if I go up to the cat and interact with it, hitting A, it makes a little sound, and the cat says meow. It's little demo stuff. If I go up to this radio, it gives me a little alert sound and says it needs batteries. It says, bro, needs a tape. Okay, get out of the dialog box, head to the other room. You can see it does a little transition there. And then we have some objects in here. We have a little glass. It doesn't do anything right now. I might give it some functionality. These are interaction objects, so usually that's for a player, like an NPC. You'll walk up and have to hit something to talk to them. Typically in a Game Boy or that era RPG, if you want to pick something up, you'll just touch it. So if I head over to this battery, it says batteries, nice. That was automatically. I didn't have to hit an interact button. Finish the interaction showing that I've read the dialogue by hitting A. Go up to the tape. Hey, you got the tape. Cool. So that means I can head up here, and it's now going to loop that song. Advance. Each time I hit it, it's spewing off a particle sprite. Those little music notes. If I hit select, I can check out a little quest list, a little menu that I haven't updated yet, but I will. Get out of there, and then I'll just close the debugger. Now, one thing, maybe we'll get into this later, you might have seen down the bottom corner there, while I was playing it, it was showing the sprite sheets of what was loaded into memory. So it'll load up a set of 16 by 16 pixel sprites, a page of those. That's the level you're on, and then it can clear that when you go and play a different one. So let's look at that on real hardware now. So with the Analogue Pocket that I've got plugged in, if I export the game as a .pocket file, it'll play right on here. So this was just a nice bit of collaboration between the GB Studio people and the Analogue people. They have a tool on the main screen here of the operating system that's got developer tools, user service, Nano Loop, which is a music tracker, and GB Studio. So if I go into GB Studio, it's first of all, it just says, hey, more information. If you don't know anything about it, you can hit that URL or that QR code. Or you can play your creations. So there's an SD card that I just put that one .pocket file onto. And you can see here's a few iterations that I'm messing around with. If I hit open, now that is playing on my Pocket, and I'll show you it on the hardware in a second too. But this is my Pocket plugged into the dock, HDMI out. I'm capturing that. I'm also looping that signal so I can see it on a little monitor down here as well. And now I can hit start. So I'm doing this all from this control. You can see I didn't re-export it, so I don't have that new menu there. But if I hit play now, you can see I moved the radio somewhere new. Talk to the cat. Hello. And you should hear sounds when I click on stuff. Yeah, there's a little delay there for I'll hear a little echo. Got a battery. It's not a very fun game right now, I must admit. And go up here and play the radio. Oh yeah, we're going to have a nice echo. Let me lower the volume on my little reference monitor. There we go, get rid of the echo. And now, since I'm not just on the debugger there, but I'm using the hardware, I can go and press hardware start, main button to quit the game. Yes, I'll quit the game. And that supports save states and things like that too. Squid.jpg says, this is a seriously impressive game editor. It is fantastic. I am so impressed. And I think, you know, this type of game accessibility to creating games really lives and dies by the game engine and development environment. It is really hard to do. You can put systems out there, but if you don't support them with easy to use, feature-rich editors, it really limits who can actually make games for them. So, you know, anyone could have always written a game for this, like in assembly language, right? But I'm not that guy. So, putting a tool out into the world like this, I'm just blown away by it. This is kind of a surface overview of stuff. I will say, just talking about pixel art for a second. For example, here's my little battery that I made. If I want to create a new asset, I can open an existing asset and modify it. So I had built that battery from scratch. Well, here's a little 16 by 16 version of one in Sprite, which is a pixel editing software. And you can see I've got a little palette up here of the acceptable colors. So I can go in here and just make this a very empty battery. And I can save that. And then when I head back into the game editor, if I make a new actor, it actually automatically puts the newest sprite it finds in the assets folder, which is great. Or you can go and pick among things. So this would allow me to put a new one, a new asset in here. Let's add an event to that just is a, how about a dialogue? That's the easiest to see. So I'm going to add a dialogue. We'll say display a dialogue. Dialogue says empty battery. And that's it. If I just go and recompile into the debugger. Look down at the bottom. You'll see as this starts, we should see sprite sheets getting loaded up. So there's the different, it takes those and turns them into as few 16 by 16 tiles as it can. So a lot of those are a repetition of just that darkest color. So those get compressed down or tiled. Come down here. Hey, look, there's my new empty battery. I can interact with it and say empty battery. If I say, oh, I don't want to have to click to talk to it. I just want that to be a collision when I walk into it. We can set that to, can I remember, movement, let me look at how I set this one up. On hit. Now I can't remember how I set that one up. Let's see. Oh, I have to set a collision group. So I can put this into a collision group so you can have different relationships between things that can collide with each other. So I can set this now on a hit with the player 1 or a group 1 or group 2 or group 3 collision object. So you could shoot it with something and it would go away. That's how we can set up little interactions like that. So now this should just that quickly not require me to walk up and try to talk to it, but instead just bump into it. And then it'll allow me to interact. You can also do things like speed up your transition here, get rid of this screen and just jump very quickly from thing to thing while you're developing. You don't always have to look at every single screen. Go down here, and now I'm just going to walk into, are you seeing that? Sorry, let me move this. I should just walk into the battery and it automatically collides with it and starts the little event going. All right. Okay, so I think we'll stop that there, but that's what I'm up to with making a game, and we'll get around more to putting it onto hardware, because that's the goal really, is to get it onto physical ROM cart, so we can plug it into any Game Boy and play that thing without having to have a fancy modern one or a hacked one or an expensive flash cart that uses SD cards. We're just going to get it onto the real ROM of a game cart. Okay, let me get a sip of water here and check physical cartridge. Yes, we want it on physical cartridge, Yanisku. Oh, and I said I would show that running on this. So let me pull that out of its thing there. Okay, so if I go to, instead of play cartridge, I can go right here to Tools, GB Studio, Play Creations. There's this is not the updated one. It's just one I saved yesterday. But there you can see, right on real hardware and lots of reflections. I hit play. Off it goes. I can crank the volume on this. Talk to that cat. There we go. Meow. Oh, pick that up. Got it. Pick that up. Got it. Very easy. And yeah, this thing has a nice loudspeaker on it too. Whoop. Stop. All right. Turn that off. And next up, I will remind you again, want to get some stuff? Want to pay tribute to the Dot Matrix Gamer, DMG? Then use this coupon code. You can do both of those things at the same time. The coupon code is DMG, and that will get you 10% off in the store today. So head over to adafruit.com and type that into the coupon code on the way out. And lastly, last thing I want to do is our continuing. Sorry, I never even walked behind the workbench today. Nothing was workbenchy. Very, very software-y today. But the last thing I want to do, speaking of software, is continue our intro to 3D modeling and CAD stuff. And today we're going to talk about, this is kind of, I think, the thing many people have been waiting for, which is parametric modeling. So parametric modeling, everything we've done so far, and as by way of further introduction, if you haven't seen the other ones, the things I'm talking about are generic concepts that run through most 3D modeling and CAD packages. I happen to be using software that I like and am very familiar with called Rhino. Rhino 3D is not free. You can do a lot of these things with some free open SCAD software, Blender, Tinkercad, Fusion 360. There's a lot of software out there, so I'm not here to try to tell you to buy some expensive software. So the things that we've looked at in the past are direct creation of stuff. So creating a line, duplicating that line, lofting objects between those lines, extruding stuff into other surfaces, and then going, oh man, I think I might have made that thing wrong. I got to redo it, or got to start from scratch, or got to change the dimensions. So while those techniques can be really useful for some things and a great way to build something directly and get a lot of knowledge about how modeling works, cut the middleman out, do it yourself, what a lot of the time we want to do is specify numeric values and the flow of data from different nodes that can set points and vectors and lengths of things, and then other nodes that can take that and say, oh, I see, let's make a box using those 4 points that you gave me. So that is what a lot of people think of when they think of CAD, is this notion of parametric modeling. So we're doing things very sort of elementally here, starting with basic building blocks. So what I'll do is let me open a scene that I prepared earlier. Actually, no, let me do it a different way. Let me just do it from scratch. Okay, so I've got effectively nothing in this scene here. So let me make a new grasshopper scene. So grasshopper is the sort of side parallel software that's running in Rhino. It's the section of Rhino that says everything that the software can do, usually by hand, we can now do with a flow graph, a DAG node, directed acyclic graph of nodes of data that can flow through each other and manipulate the data. So let's start with something in here like, can we do a rectangle in here? I think we can. Nope, not that way. Hold on. That way, does that want points, X, Y, Z? Yeah. X, width, and height. Yeah, this is a good example of it. So here's a node that, this one is not super elemental. That's probably why it's confusing me, but this one can do a few things for me. So it can accept into it a plane. So one of these maybe X, Y, Y, Z, ZX planes that the 3D world is made of. And it starts with a default of X and Y, the world XY. It can accept a dimension on X, a dimension on Y, and it should make a two-dimensional rectangle for us. So you can see here, this is a little node that has some inputs into it, and I'm going to give it some info. Let's say a slider that goes from 1 to 10. And I'll drag that into here. And I'll duplicate that and make a slider that goes into the Y. And now you can see in my scene, it's telling me a few things. It's saying, okay, we have a little representation of the plane that we're using. And now we have a way to adjust a couple parameters. So when we talk about parametric modeling, we're talking about parameters that you can adjust or that can come out of massaging the data through some math or some scripts and then getting a result out of them. So if I create this little rectangle here, and then since this one is kind of like a friendly node that knows a few things about what you might want, not only does it have the width and the height, or X and Y of this rectangle, but it also has a little slider here for a radius on the corners if you want to make a nice little rounded rectangle. So let's do a new slider that goes from 0.1 to 5. I'm in a millimeter world here, so these should be reasonable numbers here. This grid, each of these gray grid lines is a millimeter in this world that I'm using. So now you can see I've got a parametrically modeled rectangle. Cool. It goes to a circle if we go big enough with the radius there. And now we can say, okay, I can change my mind about that thing. That thing is not that interesting, but it's a rounded rectangle, neat. what do I want to do with it? Well, let's say we want to extrude it. So I'm going to, if we think back to how you can do these things by hand, you might create your little shape and then use the extrude command as sort of the next thing you do. So I'm starting with this, and then I'm going to say I want to extrude that. I'm going to give it a sort of vector. Which way do I want to extrude it? I'm going to go on the unit Z, which is up in this world here. And that can vary. Some CAD software, particularly things like AutoCAD that started out more 2D originally, will often think of Y as up and Z is back. So I'll give it a vector, which is up in the world, Z, and I'll give it a value. So let's say anywhere from 1 to 100. And pop that in there. So now I have a little parametrically modeled, sort of open, rounded box, which we can go back and adjust these parameters for. And since I don't want that thing to be open on the ends, I'm going to tell, oh yeah, and cap that, put a little cap on. So again, I'm going to add a node that's whole purpose in life is to receive a piece of surface geometry and give it caps on any planar holes that are in it. Now I can make it a little easier to look at the pieces and parts of this just with a little bit of interface that doesn't show all the nodes at once, but now I'm just previewing my rectangle, previewing my extrusion, and previewing the little cap I put on it. And we can make that a prettier preview, make it look a little more like shaded geometry by adding in a node that just renders it kind of more like this, the normal hands-on version of the software renders things. So now we have a custom material. Actually, I can just adjust the color on this. Let's do it this way. What is the material thing? It's not custom material. Is it? Maybe it is. Yeah, okay. We can change KD. Let's make this blue. And now I have geometry, and we can even go to like a rendered view, get some nice little ambient occlusion shadows on there. So we've now taken our object that we might have just created kind of hard-coded style by modeling it and turned it into a parametric model that we can go and manipulate these parameters, these values for to adjust the thing after the fact. Let's go back to a shaded view here. And this is what gives you the power of saying things like, hey, I want to make a board that fits one of our feather boards, and then a version that I can adjust and fit to a cutie pie. And I know that these are the dimensions of this board, these are the dimensions of this board, this is the radius of the holes or the diameter of the holes, and this is where they are. So all of those things you can imagine you can start to create with parameters so that it's slide it around to get what you want out of it. So if I open up a different grasshopper scene that I had made earlier, you can see, let me hide all this stuff first. And just show this one here. Oh. Here I've gone a little more elemental. So I had shown how to grab a thing that is nice because it has a few, it knows a little bit about what I want to do is this rectangle. Well, so here is getting way more granular by saying I want a node that just can construct a point, one vertex, one point in 3D space. It's this construct point, and I'm going to feed it 3 sliders. So you can see here I'm foreshadowing a little. I've actually turned it into a poly line, a single polygon line, by creating a second point. You can see it light up green over there. And again, this has little sliders that I made that sort of snap on integers of this second point. So there's a line, and that's all the input is to this node is give me 2 lines. And I can do things like spy on that info there, so I can see I have 1 at 9 on X, 6 on Y, 4 on Z. That's the first point, and there's the second, 11, 4, and 10. And then I've continued this on, similar to that previous example where I have it running through a few nodes to do things like generate a extrusion and a cap on that, and then replicate the heck out of the thing by using an array. So here you can see I have just that original box, but I can say, all right, take that flow of that thing and run that into an array, a polar array node, and I can again go and adjust the values on that. So let's see, can I do adjust the angle on that as well? So we can tighten up that angle so it doesn't go the full amount. Let's get fewer of them in there. Or we can go up to 360. Oh, this is in radians, so it's not liking, I have to run that through radians. So I'll show that as the last bit here. Let's see, radians. This will take degrees and spit out radians. There we go. So now that's a 90-degree angle. I can adjust this little slider to, oh, why won't you edit? To be able to go up to 360. 6, 3, minimum, sure, 1. So there's the full circle, and then how many instances do we want there? Now, neat thing is, since this is parametric, I'm not sort of left holding the bag of whatever the most recent thing I did is. I can go all the way back to the beginning of this and change where my points are in 3D space that make up that initial line. Okay, so very adjustable depending on your needs. Yeah, we can make a jet engine, as Andy Calloway says, or a fan. So let's see, if I have one other example in here, I think it might be best to end it there. Let me just remind myself what else I put together. That's similar to what I showed. Yeah, you've seen all that. Okay, so that's just a very, very basic intro into some of the parametric modeling, but we'll take stuff further with this. Like I've said before, let me know in the chat if you have any questions or any specific things you want to see or wondering about how the heck any of this works. But I will start, once I get through some of the basic concepts of this, I'll start doing a more concrete project where we do an enclosure for a gizmo and 3D print the thing. That kind of approach I think will be helpful. All right, I will go back and remind you, if you want to buy some stuff in the store today and save some money, head on over to adafruit.com and type in .matrix as your coupon code on the way out. Thanks so much for joining me. We are out of time. We're way over. So I gotta end this thing. Thank you everyone so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Please tune in for our different live streams that we have. I'm not sure if Scott's doing a deep dive. Is maybe on the way. Look for Foamy Guy, Tim Deep Dive. We have Product Pick of the Week on Tuesday, 3D Hangouts on Wednesday, Show and Tell Wednesday evening, Ask an Engineer. We also have Desk of Lady Ada and great searches and things mixed in there at various times. So come on by and join us. Thanks, everyone. Bye-bye.